Picture this: a telescope so powerful it peers into the dawn of time, revealing secrets that make even the most seasoned astronomers question everything they thought they knew. The James Webb Space Telescope, humanity's greatest eye in the sky, has done just that. It's uncovered something so bizarre, so utterly mind-bending, that a Nobel Prize-winning scientist has declared it's a different universe out there. Strange galaxies, impossible structures, and clues that our cosmos might not be what it seems. These discoveries are rewriting the rules of reality itself. Buckle up, because what follows is a journey into the depths of space, where the unthinkable becomes possible, and the universe reveals its most shocking truths. This is a story of cosmic rebellion, emotional awe, and a telescope that's changing everything. Let's start with the bombshell that's got the scientific world buzzing. Deep in the cosmos, near the familiar stars of the Big Dipper, the James Webb Telescope spotted faint glimmers of light. Light that's been traveling for over 13 billion years. These aren't just any lights. They come from galaxies that formed a mere 500 to 700 million years after the Big Bang, when the universe was still in its infancy. But here's the kicker. These galaxies are massive, as big as our Milky Way is today. That's not supposed to happen. According to everything we know, the early universe didn't have enough matter, enough time, to build galactic giants like these. Scientists have dubbed them universe breakers, and for good reason. They shatter the standard model of cosmology like a hammer through glass. Imagine the shock in observatories around the world. Astronomers expected to find small, scrappy star clusters struggling to form in a chaotic young universe. Instead, they're staring at fully fledged galactic heavyweights, strutting their stuff when the cosmos was barely out of diapers. It's as if you walked into a nursery and found a toddler bench-pressing 500 pounds. These galaxies are too big, too bright, too everything, and they're not alone. In the months that followed, the telescope kept finding more of these cosmic anomalies, galaxies that are far too starry for their age, defying every prediction about how stars and galaxies should form. But the surprises didn't stop there. The telescope also confirmed something even more unsettling. The universe is expanding at a rate that doesn't add up. For decades, scientists have relied on the Hubble constant to measure how fast the cosmos is stretching. On paper, calculations based on the Big Bang model give a value of about 67 kilometers per second per megaparsec. But when astronomers look at real data, supernovae, red giant stars, gravitational lenses, and variable stars, they get a different number: 73 kilometers per second per megaparsec. That's a gap so wide, it's like measuring your house and finding it's 20 feet longer than the blueprint. The James Webb Telescope's latest observations have only deepened this mystery, confirming the higher value and leaving scientists scrambling for answers. So what's going on? How can the universe be so defiant of our expectations? One jaw-dropping theory is that our universe isn't alone. What if it's colliding with other universes, merging in a cosmic dance that's been hidden from us until now? Picture this. Shortly after the Big Bang, our fledgling cosmos might have been swallowed by a larger mother universe, sparking the rapid expansion we call inflation. Scientists have built mathematical models to test this idea, and the results are stunning. A universe interacting with others would grow in ways that better match what we see in the sky, those impossible galaxies, that stubborn expansion rate. It's a theory so wild, it sounds like science fiction, but the numbers don't lie. They suggest our universe might be part of a vast multiverse, a tapestry of realities woven together in ways we're only beginning to grasp. This isn't just about numbers and equations. It's about the emotional weight of realizing our place in the cosmos might be far stranger than we ever imagined. Think about it. Every star you see, every galaxy the telescope reveals, could be part of a story that stretches beyond our universe, into realms we can't even picture. It's humbling, exhilarating, and a little terrifying. The James Webb Telescope isn't just showing us stars, it's showing us that our understanding of reality is incomplete, that there's so much more to learn, so much more to feel. Let's dive deeper into one of the most puzzling discoveries yet, a galaxy called GSZ 11-1, spotted just 330 million years after the Big Bang. This isn't just another cosmic oddity, it's a galactic rebel that's rewriting the history of the universe. GSZ 11-1 is pumping out ultraviolet radiation so intense it's lighting up the cosmos in ways that shouldn't be possible. According to our models, the early universe was cloaked in a dense fog of neutral hydrogen, a cosmic haze that blocked shortwave radiation like UV light. This fog wasn't supposed to clear until much later, when young stars and galaxies had time to ionize the hydrogen, creating bubbles of transparent space. But GSZ 11-1 is having none of that. Its UV light, specifically something called Lyman alpha radiation, is blasting through a bubble of ionized gas that stretches 650,000 light-years across. That's bigger than anyone thought possible at this stage of cosmic history. The discovery left astronomers speechless. One researcher put it bluntly, "We shouldn't have found a galaxy like this at all." The spectral data is crystal clear. GSZ 11-1's light is reaching farther, shining brighter than our theories allow. This suggests one of two things. Either the process of reionization, when the universe went from opaque to transparent, started much earlier than we thought, or it happened way faster. Either way, our timeline of cosmic evolution is in tatters. And here's the emotional punch. This tiny galaxy, born in the universe's earliest days, is forcing us to rethink the very foundations of cosmology. It's a reminder that the universe doesn't care about our textbooks. It's out there, doing its thing, daring us to keep up. What could be causing this? Scientists are buzzing with possibilities. Maybe GSZ 11-1 is home to a population of ultra-hot, luminous primordial stars, the kind that could ionize hydrogen at a breakneck pace. Or perhaps there's an active black hole at its core, gobbling up matter and spitting out radiation with ferocious energy. Both ideas are thrilling, but they also raise more questions. If these early galaxies are so powerful, why didn't our models predict them? And what does this mean for the bigger picture, the story of how our universe came to be? This brings us to the heart of the most radical idea yet. What if the Big Bang wasn't the beginning? What if it was just a chapter in an eternal cosmic saga? A Nobel Prize-winning physicist has been shouting this from the rooftops, and the James Webb Telescope's discoveries are lending weight to his bold vision. He argues that the universe operates in a cycle of destruction and rebirth, a never-ending loop where each cosmos expands, collapses, and explodes into a new existence. Instead of a singular Big Bang, we get a big bounce, a moment of transition from one universe to the next. It's a concept that's both mind-boggling and deeply moving. Imagine a universe that's not a one-off, but a story told again and again. each cycle leaving echoes of the last. The evidence for this cyclical universe is as tantalizing as it is controversial. In the cosmic microwave background, the faint glow left over from the Big Bang, researchers have spotted strange circular patterns, hotter than their surroundings, scattered across the sky. These Hawking points, as they're called, could be the ghosts of supermassive black holes from a previous universe. The theory goes like this. At the end of a cosmic cycle, black holes evaporate into Hawking radiation, carrying their energy into the next universe. There they appear as these eerie spots in the microwave background, like cosmic fingerprints of a world long gone. Each spot is roughly the size of the full moon in the sky, a haunting reminder that our universe might have a predecessor. The scientific community is divided. Some call these findings groundbreaking. Others say they're speculative at best. But the Nobel laureate behind this theory isn't fazed. He points out that black holes themselves were once dismissed as mathematical fantasies. Yet today, they're undeniable realities. Could the same be true for these Hawking points? The emotional resonance of this idea is undeniable. It's not just about science. It's about the possibility that our universe is part of something bigger, something eternal. Every time you look at the stars, you might be seeing echoes of a cosmos that came before, a legacy written in light and radiation. Let's step back and take in the bigger picture. The James Webb Telescope has turned our understanding of the universe upside down. Those universe-breaking galaxies, the mismatched expansion rates, the rebellious GSZ 11-1, they're all pointing to the same truth. We've been wrong about the cosmos. Our standard model, built on decades of careful study, is cracking under the weight of these discoveries. And that's not a failure. It's an invitation. An invitation to dream bigger, to question deeper, to feel the awe of a universe that's far wilder than we ever imagined. Consider the cosmic dawn, that pivotal era when the first stars ignited, banishing the darkness of the early universe. We thought we had it figured out. Stars formed slowly, ionizing hydrogen bit by bit, creating small bubbles of light in a sea of fog. But the telescope's data tells a different story. Galaxies like JWST 11-1 suggest that smaller, less massive galaxies played a bigger role in ionization than we thought. Their intense radiation carved out massive bubbles of ionized gas, transforming the universe faster than our models predicted. It's a story of underdogs, tiny galaxies wielding outsized power, reshaping the cosmos in ways we never expected. This discovery tugs at the heartstrings. It's not just about physics. It's about the resilience of the universe itself. In its earliest days, when everything was chaos and darkness, these small galaxies fought against the odds, lighting up the cosmos and paving the way for everything that followed. It's a reminder that even the smallest players can change the course of history, whether it's a galaxy in the early universe or a single person chasing a dream. But the telescope's revelations go beyond galaxies and radiation. They challenge the very nature of reality. If our universe is merging with others, if it's part of a cyclical chain of creation and destruction, what does that mean for us? Are we just one chapter in an infinite book, our story destined to fade into the next? Or does our existence carry a deeper meaning, a connection to the countless universes that came before? These questions aren't just scientific, they're profoundly human, stirring feelings of wonder, curiosity, and even a touch of existential dread. The James Webb Telescope is more than a machine. It's a storyteller weaving a narrative of a universe that's stranger, more beautiful, and more complex than we ever dared to dream. Every image it captures, every spectrum it analyzes, is a chapter in that story, inviting us to turn the page. And as we do, we're forced to confront the limits of our knowledge, the fragility of our assumptions, and the boundless potential of what lies beyond. Let's talk about the emotional impact of these discoveries. Imagine standing under a starry sky, knowing that the light you see might carry secrets from a universe that existed before ours. It's a feeling that blends awe with humility, a sense that we're part of something vast and eternal. The telescope's images aren't just data, they're windows into a cosmos that's been unfolding for billions of years, a cosmos that's still full of surprises. Each discovery is a reminder that we're explorers, forever chasing the unknown, forever reaching for the stars. And the stakes couldn't be higher. If the cyclical universe theory is right, it changes everything. It means the Big Bang wasn't a singular event, but a moment of transformation, a bridge between one cosmos and the next. It means the universe is a process, not a product, a living, breathing entity that reinvents itself over and over. The Hawking points in the cosmic microwave background, those possible relics of a lost universe, are like messages in a bottle, whispering that our story is part of a larger tapestry. Even if the cyclical model isn't correct, the telescope's findings demand that we rethink our place in the cosmos. Those universe-breaking galaxies, with their impossible size and brightness, suggest that the early universe was far more dynamic than we thought. Maybe it was filled with bursts of star formation, fueled by processes we don't yet understand. Maybe black holes played a bigger role, shaping galaxies with their relentless gravity. Or maybe there's something entirely new at play, a force or phenomenon we haven't even named yet. The beauty of these discoveries lies in their mystery. They don't just give us answers, they give us questions, each one a spark that ignites curiosity and wonder. And that's what makes the James Webb Telescope so special. It's not just showing us the universe, it's showing us ourselves, our drive to explore, our need to understand, our capacity for awe. Every pixel in its images is a testament to human ingenuity, to the dreamers and scientists who dared to look beyond the horizon. Let's zoom in on another stunning find: the telescope's ability to detect galaxies that challenge our understanding of star formation. In the early universe, stars were supposed to form slowly, building galaxies over billions of years. But the galaxies the telescope has found are bursting with stars, far more than our models predict. Some are so bright, they outshine modern galaxies, despite being billions of years younger. It's like finding a city of skyscrapers in a place where you expected mud huts. This raises a thrilling possibility. Maybe the early universe was a hotbed of cosmic creativity, a place where stars were born in furious bursts, driven by conditions we can't yet replicate in our simulations. Perhaps the first black holes, formed from the collapse of massive stars, played a role, their gravity pulling in gas and sparking star formation on a massive scale. Or maybe there was something else, a primordial energy source, a quirk of physics that turbocharged the process. Whatever the cause, these galaxies are a testament to the universe's boundless energy, its refusal to play by our rules. The emotional weight of this discovery is profound. It's not just about stars and galaxies, it's about the universe's capacity to surprise us, to exceed our wildest expectations. When you look at an image of one of these ancient galaxies, you're seeing a snapshot of a time when the cosmos was young and wild, a time when the seeds of everything we know were sown. It's a connection to the past, a reminder that the universe has been shaping itself for eons, and we're just now catching up. But the telescope's discoveries also carry a sense of urgency. If our models of the universe are wrong, if the Big Bang isn't the whole story, then we need to act fast to understand what's really going on. The data pouring in from the telescope is a treasure trove, but it's also a challenge. Scientists around the world are racing to analyze it, to build new theories, to test wild ideas, and they're doing it with a sense of excitement that's infectious. This is science at its best, bold, curious, and unafraid to admit when it's wrong. Let's not forget the human side of this story. The James Webb Telescope is the result of decades of work, of countless people pouring their hearts and minds into a single goal: to see the universe more clearly. Engineers, scientists, programmers, dreamers, they all came together to build this marvel, a machine that's now revealing truths they could only imagine. Every discovery it makes is a tribute to their passion, their perseverance, their belief that the universe is worth exploring. And what about you, the viewer? You're part of this story too. Every time you marvel at a new image from the telescope, every time you feel a spark of wonder, you're joining a journey that's been going on for centuries. The universe isn't just out there, it's in you, in the questions you ask, in the emotions you feel. The James Webb Telescope is a bridge between you and the cosmos, a reminder that we're all connected, all a part of the same grand adventure. So where do we go from here? The telescope is still scanning the skies, still sending back data that's turning science on its head. In the coming years, it will probe even deeper, looking for clues to the universe's earliest moments, searching for answers to questions we haven't even thought to ask. Maybe it will confirm the cyclical universe theory, showing us that our cosmos is just one link in an infinite chain. Maybe it will reveal new forces, new phenomena that rewrite the laws of physics. Or maybe it will surprise us in ways we can't even imagine. One thing is certain: the universe is bigger, stranger, and more beautiful than we ever thought. The James Webb Telescope is our guide, our storyteller, our window into that strangeness. And as it continues to explore, it's inviting us to come along, to feel the awe, to embrace the mystery. This is more than a scientific revolution, it's a human one, a chance to see ourselves reflected in the stars, to find meaning in the vastness of it all. Let's end with a moment of reflection. The next time you look up at the night sky, think about what the James Webb Telescope has shown us. Those stars, those galaxies, might be more than they seem. They might be echoes of a universe that came before, or harbingers of one yet to come. They might be part of a multiverse, a cosmic tapestry that stretches beyond imagination. Or they might simply be a reminder that the universe is full of surprises, waiting for us to discover them. This is the power of the James Webb Telescope. It's not just showing us the cosmos, it's showing us what's possible. It's igniting our curiosity, stirring our emotions, and reminding us that the universe is a place of wonder, forever calling us to explore. So let's answer that call. Let's keep looking, keep questioning, keep feeling the awe. Because out there in the depths of space, the universe is waiting to tell us its next secret. And when it does, we'll be ready. Hearts open, minds ablaze, ready to embrace whatever strange, beautiful truth it reveals.